Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we are going to learn about a new system of numbers called complex numbers. To know about complex numbers, let us first take an equation x square plus 2 equal to 0 or x square equal to minus 2. We know that there is no real number which satisfies this equation, as square of a real number cannot be negative. Here x square is equal to minus 2, which is a negative number. So we don't have any possible solution for this equation. While solving such equations, a new set of numbers called complex numbers came into existence. A complex number does not mean a complicated number. It means that two types of numbers, real number and imaginary number, together form a complex, just like a building complex. Thus, a complex number is formed by combining a real number and an imaginary number. Or we can say a number of this form, a plus b iota, where a is called real part and b is called imaginary part. Iota is equal to square root of minus 1 is called imaginary unit. Thus any number of this form or any number that we can put in this form is called a complex number. Let us take an example. We have 7 plus 3 iota. Here 7 is called the real part and 3 is called imaginary part of this complex number. Let us take few more examples. We have 2. 2 is a complex number because we can write 2 as 2 plus 0 iota. Also 0 is a complex number because we can write 0 as 0 plus 0 iota. 6 iota is a complex number. We can write it as 0 plus 6 iota. All these three numbers, 2, 0 and 6 iota, are complex numbers, where 0 and 2 are purely real and 6 iota is purely imaginary. Let us take few more examples. We have 3 plus 2 iota. It's a complex number and 3 is real part and 2 is its imaginary part. Also 5 is a complex number. Its real part is 5 and its imaginary part is 0. This complex number is purely real. One more complex number is minus 6 iota. Its real part is 0 and its imaginary part is minus 6, and this number is purely imaginary. A complex number in which iota is absent, that complex number is called purely real, and a complex number in which real part is absent, that complex number is called purely imaginary. Now let's talk about imaginary unit iota. Iota is equal to square root of minus 1. That means iota square is equal to minus 1. Thus iota cube is equal to iota square into iota. Iota square is minus 1, so iota cube is minus 1 into iota. That is equal to minus iota. Iota raised to power 4 is equal to iota square into iota square. Iota square is minus 1, so we get minus 1 into minus 1, that is equal to plus 1. So iota raised to power 4 is equal to plus 1. Now let us generalize it. Iota raised to power n is equal to 1 if n is equal to 4m. That is, if we divide n by 4, we get 0 as remainder. In that case, iota raised to power n equal to 1. Example, iota raised to power 100 equal to 1. Because if we divide 100 by 4, we get 0 as remainder. Similarly, iota raised to power n is equal to iota if n is equal to 4m plus 1. That is, if we divide n by 4, we get 1 as a remainder. Example, iota raised power 101. If we divide 101 by 4, we get 1 as remainder. So iota raised power 101 is equal to iota. Now we have one more case, that is iota raised power n is equal to minus 1 if n is equal to 4m plus 2. That is, if we divide n by 4, we get 2 as remainder. Example, iota raised power 102 is equal to minus 1. If we divide 102 by 4, we get 2 as remainder. Now let us take one more case, that is iota raised power n is equal to minus iota if n is equal to 4m plus 3. That is, if we divide n by 4, we get 3 as remainder. Example, iota raised power 103 is equal to minus iota. If we divide 103 by 4, we get 3 as remainder. We generally denote a complex number by z. Now let us talk about algebra of complex numbers. Addition of two complex numbers. For addition of two complex numbers, we add real part with real part and imaginary part with imaginary part. Also, the addition is closure. That is, if we add two complex numbers, we get a complex number. Now, the commutative law. If we have two complex numbers, z1 and z2, then z1 plus z2 is equal to z2 plus z1. The associative law. If we have complex numbers z1, z2, z3, then z1 plus z2 plus z3 is equal to z1 plus z2 plus z3. Existence of additive identity. For any complex number z, there exists the complex number 0 equal to 0 plus iota 0, such that z plus 0 is equal to z. Existence of additive inverse. To every complex number z equal to a plus iota b, there exists a complex number minus z equal to minus a plus iota times minus b, such that z plus minus z equal to 0. Now we have few more properties on multiplication of complex numbers. If we have complex number z1 equal to a plus iota b and z2 equal to c plus iota d, then z1 into z2 is equal to real part of z1 into real part of z2 minus imaginary part of z1 into imaginary part of z2 plus iota times real part of z1 into imaginary part of z2 plus imaginary part of z1 into real part of z2. Closure property. If we multiply two complex numbers, we get a complex number. The commutative law. Product of two complex numbers z1 into z2 is equal to z2 into z1. Associative law. z1 into z2 into z3 is equal to z1 into z2 into z3. The existence of multiplicative identity. There exists a complex number 1 equal to 1 plus iota into 0, such that z into 1 is equal to z. The existence of multiplicative inverse. For every non-zero complex number z equal to a plus iota b, there exists a complex number 1 by z equal to 1 by a plus iota b, such that z into 1 by z is equal to 1. The distributive law. For complex numbers z1, z2 and z3, z1 into z2 plus z3 is equal to z1 into z2 plus z1 into z3. Also, z1 plus z2 into z3 is equal to z1 z3 plus z2 z3. Division of two complex numbers. For any two complex numbers z1 and z2 such that z2 is not equal to 0, the quotient z1 by z2 is defined by z1 by z2 equal to z1 into 1 by z2. Now, equality of two complex numbers. Two complex numbers a plus iota b is equal to c plus iota d if and only if real part is equal to real part and imaginary part is equal to imaginary part. That is, a is equal to c and b is equal to d. Now, in my next lecture, I will continue this topic. Till then, take care of yourself. Thank you.